All right, let's begin. So, yeah, Damon.
I got a question already.
What the fuck?
So, talking about closures.
Okay.
How exactly does the inner scope retain the outer scope's like arguments? Like, how does that even work?
Like mechanically?
Yeah. If that's a question you can answer.
Yeah. So, somebody helped me through the closure example from yesterday.
Like,
Help me make a closure. Somebody who isn't Damon. Function.
Outer.
Mm-hmm.
Asking like X.
Cool, then what?
return.
Return. That's the key part.
Function inner.
And then like yesterday we were doing something like return X times Y. Okay. And the reason that inner can see X is it accesses it via closure. So in practice, this gets used like outer 3, 4. Cool. Makes sense so far? So keep in mind that when we write JavaScript, like these are suggestions to a compiler that compiles it down to C, which compiles it down to machine code, which compiles it down to oops boops. So when we have, let's say we did this in 2 steps. We don't have to do it all together. We could say something like const inner equals this was supposed to be a function. Something like outer 3, and then in a completely separate step, do inner 4. Those do the same thing, right? So so how does it know that that 3 is there? Well, the reason is it knows that there's a reference to it right here. And so since that reference is there, it knows it needs to hang on to it, even though this outer scope doesn't exist anymore. It makes a little note. It's like, I gotta hang on to this. And actually, that ends up being a problem for performance sometimes. Imagine that X is X and Y and Z, and those are fucking huge objects, and we're doing this in a loop, so we're making a lot of them. Let's say even you're not doing something all that important with the X either. You're just doing console log X. It's hanging on to that reference and using memory for it. Closures can fuck your performance because you're just hanging on to so many references. But since it knows you're going to use it, it allocates space for it and like keeps a little note of where it is in memory. So when it's time to use X, it goes, cool, where was that stored? Also, don't clean that up. JavaScript cleans up code that isn't being used anymore as it runs. When you keep these references around, it doesn't garbage collect them. And
So, is it being able to point at X, like is keeping X guaranteed part of being immutable, like what you want to write your code functionally so that X won't change it in code?
yes, like you do. That's not like, and that's mostly just a like a sanity thing. If that can dynamically change, I don't know how you would understand that code. That's just hard for your human compiler. Cool. All right, Damon, you asked. Explain this to me. How come the inner function can see X even though outer is done?
Well, it needs to remember X. Would that be like, it's not actually making a variable since function,
Well, it's got a memory address. It's getting stored somewhere. You are not writing a variable for it. I mean, you kind of are. I mean, that's a variable.
Yeah.
But, yeah, let's keep a note of that.
And then the next time you use that function, it will actually overwrite it and use memory, or will it still persist?
We'll make a new one.
Like a new one?
Because remember, like when you write a function, this is like a pattern. It's not really doing anything until you invoke it. Each time you invoke it, that pattern, like these are getting swapped out for what you actually pass in. So if you're invoking it 20 times, yeah, there's 20 different x's that are stored somewhere. And since it knows it's doing a reference there, it knows it has to keep track of that.
So how is that not state? Isn't state just referring to any one of your string?
So think of it this way. Good question. It's only state if we stop. This is not stateful. It just runs. It's equivalent to 12. Remember our referential transparency? Those are the exact same thing. So anything we can do with 12, we can also do with this. There was no state there because it was never like retained. Here, not so much. We actually have a point where we stop, and now this is being stored and retained, and then we do something else with it. Style-wise, like semicolons kind of fell out of favor, but you put semicolons after statements. Holy shit, I never picked up on this before. It's right in the word. Statement. So like your hypothetical perfect functional programming has one statement in it.
Actually makes it a lot easier to like figure out what state is.
There you go. But like these happen in order, like here, it's one statement, but like we still live in a world where time exists. We're trying to not represent time in our code though. Cool, what else? Yeah.
Do you know what function can return function either y?
Yep.
Leave
Oh yeah, you could leave it off. Here's another way we could write that entire thing. And this is a lot more like what you would see functional people do. You might say const outer equals x, y, x times y. This whole thing would be written like this most of the time. Unsurprisingly, looks way more mathy. But they're identical. The fat arrow, that makes a function. If it's on the same line, it returns whatever you get. So if you imagine putting some parentheses around this, like our innermost function is that. The thing that it's returning in here is this. And the thing that this function is returning is all of this. So it's a function that returns a function. It's a function that returns a function. Way more terse syntax. I think it's a lot harder to read, but like that's what like functional notation kind of looks like. It's actually why the fat arrows got added to JavaScript. It's why they implicitly return them all in one line. Make FP people happy. It's all for you, Damien. Cool. What else?
So, if for some reason you leave the outer function an argument,
Mm-hmm.
the inner function wouldn't use, or wouldn't retain that pointer to it, right?
Correct.
For some reason.
Exactly, because like it doesn't have a reference to it, doesn't keep track of it. Good question.
I guess
try to eliminate time.
Yeah. How does that work though? Like, so you don't have any dependencies, like nothing is,
You never stop. There's no pause point.
but does it still read it from top to bottom?
Yes. Well, it evaluates it from top to bottom. Like, before I can adequately do, like, multiply this time, or curry this with whatever's happening here, I need to know what this is. But it never stops. It just evaluates everything as it needs to. It's like simplifying a problem or something in math. Or reducing fractions or anything like that. So the compiler does that in order and whatever else, but like we don't control it. We never told the program to stop. That's what getting rid of time means in this situation. Okay, we talked about these FP principles yesterday. Let's review. I want you to look at these. Think about how you come home and the programmer you live with goes like, oh, cool, tell me about immutability. Heard you learn about functional programming. Figure out what you would say for each one of these. I'm gonna do some cold calls. It's all right if you don't remember it, you don't got it. That's fine, it's the entire point of this. But let's take a little bit to figure out what you might say. All right, let's talk to some folks. Immutability. Katie, how would you describe immutability?
Once you assign a value to something, that value's not going to change.
Correct. Very nice. So yeah, we don't mutate anything that's already been set. And so if you're wondering, all right, well, sometimes I do need to mutate stuff. I need to add stuff to arrays, I need to remove stuff from arrays. There are other ways that you can express that. But fundamentally, you're always making a copy of it that you can then, it's an array based on this other array. So like you maybe spread the existing array into it and then comma whatever your new element is. That's how you change something instead of changing what the original one was. Very nice. Purity. Muhammad, what is functional purity? Okay, cool. Let's who can help Muhammad out with that? Ben.
So basically, a single input can produce one single output.
Yes. I really like that. So, Muhammad, your own words, what's functional purity? For a given input. That's the important part. So think about our I/O table that we use like in whiteboarding. If I have an I/O table and I say, cool, if you give me cat, I give you tack. What would violate this is if I give you dog. Well, I suppose it depends on the state of this other variable before I know what I can give you, but it could be any number of things. That's not pure. So think about all the times you've done, let's actually rewrite that closure example. So I have function something that takes in x, and I've set y out here equal to 3, and this returns x times y. We can still do this, this works, but now this function isn't pure. Because if I give this 3, what comes out of that depends on something that isn't in the function. That's not pure. Whereas if I pass in x and y, now it's pure. The output is completely dependent on the input, not any what we call indirect input to the function.
That's like a side effect.
Almost. It's the same kind of thing as a side effect. Side effect goes the other direction though. Side effect, who can explain to me side effects? Colin.
Side effect is basically anything that is coming out of a function that isn't exactly what you're returning.
Yes.
So if you were changing y inside of the function.
Yes. Y equals 2. That has a side effect. Because I'm doing something other than just returning a value. That means this function isn't pure anymore either. What's a kind of side effect that we need to have at some point in the application? Output. We got outputs, usually something to a screen, but even more generally, it could be printing out a receipt, it could be any of those kinds of things. Those are side effects also. What do we do with those side effects? Push them to the end. Do all of your transformation with these pure functions, and only then you do all your side effects at the same time. That's what we're going for with purity. Cool. Disciplined state. Lizzie Tom, what do you think disciplined state is all about?
Let me read up on my notes real quick.
Okay, that's fine. While she's doing that, Colin, what do you think?
I was actually going to ask, like, practically, what does it look like when you're pushing side effects to the end?
Oh, absolutely. It's a really good question. Like, in a very literal sense, it's probably something like, all right, I map over something and I double it, and then I filter out less than 5, and then I do something else, some other pure transformation, and then at the very end of this, I for each, and then console log it. That's a side effect. I have pushed it to the end. I've done all of my data transformation first.
So it's not that functional programming doesn't have side effects, but
You control them. Similar to disciplined state, in that if our application, remember, like, this is the model of almost every application. Well, it is at every application. We take in input, we do something with it, and then we generate output. This is the side effect right here. And we're trying to make sure that everything else that happens inside the box is pure.
so return value always a side effect?
Not return values, output to the screen. Puts in Rails are not Ruby. Cool. What else? Lizzie, what'd you find?
So for discipline state, it's you want to try and keep your variables within functions, because variables are state.
Correct. Sometimes you can't get away from state. For example, map needs to get implemented at some point. Like, we get it for free in the language, but like, what do you think that's doing under the hood? Probably uses loops and variables and all these things that we're not allowed to use. But they're contained within that and they don't leak out. And so it gives us a lot more confidence that like map doesn't have any side effects, and I can write my code in a functional manner, even if under the hood this is using ifs and whiles and variables and all kinds of other things. It's just localizing that. Very nice.
So, do you, like, never do anything, or do you just keep them local? Like,
You're being disciplined about it. So if for whatever reason it makes sense to do those, we're keeping them wrapped up in something that we trust, and then we're using that thing, that abstraction that we made up.
But I guess the argument is also, why do you need a variable if it's going to be constantly moving?
There's also a concept, speaking of no variables, called point-free programming. Point-free programming is elegant AF. And like, it looks like this. Something like that. You're never actually naming the arguments to it. That's point-free programming. Each like named parameter for something is a point in like math terms. Cool. Referential transparency. Think to yourself. Andrew, what's referential transparency?
Expressions that equate the same way even if you change the variables between. Where they keep things that are the same, even though they include different.
Yes. I would say that like that's an application of it, but really it's that an expression is the same thing as what it evaluates to. So we can do all the same things with those. So if I have 12, well, I can call the toFixed method on 12. I could also do that with 4 times 3. Or a function called 12 that returns 12. I invoke it. That's equivalent to its return value because of referential transparency. And I can do anything with that that I could do with 12. Beautiful. Type systems. JavaScript's not super good at them, but it's worth kind of knowing what they are. Chris, tell me everything you know about type systems. Cool. We can help Chris out.
You prevent the compiler from those mistakes at the front because you tell them what type of argument that the function or whatever it is. So
Indeed.
you can't pass them over.
Yeah?
So is like, TypeScript a type system?
Yes. That's exactly what it is. So, if we're doing that function where we are returning x and y, in JavaScript these can be anything. They can be, we can pass in a string and a number. Who fucking knows what happens when you do that? A type system is saying, by the way, this is a number, ergo, this always produces a legal value. That's the power of a type system. And we can make up our own types too. We can say, all right, when you add a person and a person, you get a group, and a group is another type, something like that. You're defining an algebra for how the operations that you can take on something. It's a lot like using classes and OOP was. All right, so that was a little heady. Chris, in your own words, tell me what you know about type systems.
You can define the type that goes in the function and out.
Yes. Very cool. And then anything else we want to add to our conceptual understanding of type systems? Yeah, Gage.
If you declare the type, let's say it was a string, you say it has to be a string, you try to pass something else in, like a number, or just do an error.
There was an error. Yep.
What's the error message look like?
Type error, usually. You guys got these all the
Yeah.
time in Ruby. Was expecting a number, got a string. That's like Ruby's is not killer, but Ruby has an alright type system. Yeah, Damon.
Where would you declare something like that if you're making your own types?
In JavaScript, you do it with prototypes. So well, like I said, JavaScript's type system is kind of garbage. It doesn't lend itself well to this kind of thing. But you might make a function or a class or something like that, and you can make objects that inherit from it. It works very similarly to how inheritance works in Ruby. It's a slightly different mechanism for doing it. That's the closest thing that JavaScript has to a type system.
This is probably totally different syntax, but like, would you have to create a new prototype, or like a new type? Like, I noticed with array.prototype, you know, you could do something with an array, you could do with an array. What would you do if you had, for example, a person?
Sure.
How would you gain access to person? type thing?
You would do something like const person equals this is all class does under the hood.
Oh.
So it's actually a function.
Does this one
technically.
need to now have the ways of
Yes, yes it does. But it's what we call a syntax trigger around this pattern. And then we say Kyle is, we can do new person, or we can say a new person, and if it's a function, then we can like pass in or you could do something like Kyle dot prototype equals person, and now I have those properties in there. Or if I had behaviors or something, now I have those too. And like for type system purposes, I can check if not x dot prototype equals person, then reject it. As I said, it's not a particularly good type system. TypeScript is a big improvement on it, and like hardcore functional languages tend to have very robust type systems.
So what's the difference between, the strong type
Mhm.
language and just like TypeScript? Or why wouldn't you, if you're using a type system, why wouldn't you always have it be like, you have to explicitly use, like it won't even run or compile unless
Oh, you generally do. Like in functional languages that have strong type systems, like almost all of them are strongly typed.
Oh, okay.
Those go hand in hand usually. Cool. Last one. First class and higher order functions. Cody, what can you tell me about first class and higher order functions?
They have the same properties as the string values.
Yep.
like in the definition.
Yep, so that's first class. We can store them in variables, we can pass them around, we can return them, we can do all kinds of crazy shit. Okay, Cody, what's a higher order function? Okay, while Cody's looking that up, volunteer to tell me what a higher order function is. Cat clause.
You can pass a function into another function,
Or,
or return a function from a function,
or,
or
both. Yep. Cool. So, Cody, what's a higher order function?
It's a function if you're able to pass in the function, can return a function, or it could be both.
Beautiful. So, passing in a function, huh? Where are some times where we do that? We pass in a function to something. What do you hear? Yeah, when you map over something, takes in one argument, it's a function definition. Any guesses what that does? Like if we were going to write our own map function, what it would look like? Let's give it a shot.
Is that kind of like what we did in English?
Probably. Like,
Before we learned how to use math, you could just use each for everything.
So what if we, okay, I'm going to touch index.js. Cool, we're defining map. What does it take in? Think about our map that we use. We just said, I heard it over there. A function. So I'll call it some function for right now. Okay, cool. And then just for the lols, I'm going to say that it also takes in an array as like a second argument. Okay, so I have an array and I have a function. What do you think I do?
You start by creating an empty new array.
Cool. Awesome, what's next? I like it. Good on you. What happens in between?
It runs that some function that new array, eventually push it into that new array.
Yeah. Let's do this like super procedural. Let's do it with a for loop. Aaron, get me started.
For I equals 0.
Oop. Let I.
Let I equal 0. I is less than the length of the array, or array dot length.
Okay.
And I plus plus.
Okay. Now what?
And then I would assume you run some function with the argument being array I.
Cool. What do I do with that?
You take a return value and push it into the new array.
Okay. Cool. Let's see if it works. I'm going to make a function called double. In the map double, and it wants you to double the things in this array. If I do that, oops, helps if I log it. Side effects, baby. We just implement a map. That's what that looks like. We passed in a function like it was a variable, and we did something with it. Now we have all the same flexibility that we have with map. That can be double, that can be add exclamation points, that can be more useful things. Cool. So I said I wanted to do the exercises from this, and I do. So what I'd like you to do is you go to the Flatiron site, mod 3 FP. I want you to give this a shot. I'm going to put 6 minutes on the clock. Start by just copy pasting this code and see if you can satisfy all of these criteria. If you can't, see how many of them you can satisfy. Go! Or 30 seconds. All right. So, let's copy this in. First thing I'm trying to do, no declared variables. Where do I have declared variables? Loud teacher, teachers, and I. Cool, so I got to get rid of those. So probably easiest way, let's do this in like little bitsy steps. What if I tried eaching over this? I did something like, I'm trying to get rid of that teachers variable. What if instead of that, I'm doing a for each? Because referential transparency, right? I can sort in a variable first. Don't have to. So I could say, all right, that's a teacher. And then for each one of them, I do that. And then I can even just console log that directly. And if I run this, teacher's not defined. Teach. Cool. If I try to run that, cool. I get my loud teachers. So I currently have no declared variables. Neat. Do we have any mutable state? What do you think? Is any state being mutated? Where?
It's changing new rates to include the explanation piece on them, so it's not like a new rate, it's the same rate.
Ooh, have I changed this though? This still exists. I'm taking values out of those and pooping them out to the screen. But this original array never mutated. Have I mutated any state? Yeah, I don't think so. Nothing's being reassigned. Okay, are side effects pushed to the end? Ooh, I'm seeing a split room here. Arena thinks so. Why do you think I've pushed the state to the end? What's your argument for? Okay, so that's my side effect. And it's kind of at the end here. Damon, why do you think that I didn't push side? Yes. So it's doing it every time. I'm still recalculating. I'm still doing work and then logging it. Work, log, work, log. Okay, so I've not pushed my side effects to the end. Am I using pure functions? Okay, why am I not using pure functions? Yeah, I have a side effect in my one function. Okay? And then no anonymous inline functions. Am I using an anonymous inline function? Okay? Yeah, fat arrow. anytime we're doing this, especially as the argument there, we're declaring the function and passing it in at the same time. All right, so let's start with that one. That's the easiest. How do I extract that? Let's start with function. What am I going to call it? Print. I also happen to be making it loud, so I'll say like print loud. I'd say teacher, but it could really be anything. Okay, now what? Yep. Well, I'm printing it also. So you really just take the whole body of that. And now, no more anonymous inline functions. Still work? Nope, because it's called string. Cool, works. So the ones that I was not satisfying, pure functions and push the side effects to the end. I'm not doing that. What two things am I jamming together? And printing it. So how do you think I'm going to get around that? Yeah. Okay, what am I going to map? What am I doing? Love it. Maybe I call that Lowbeautiful. And I can return just a string with an exclamation point. Neat. Pass that in. And now, this can really just be print, right? Can I run it? Still works. No declared variables. I don't see any. No mutable state. Don't see any. Push the side effects to the end. You betcha. Uses pure functions. Yup. No anonymous inline functions. I don't see one. Cool. Let's compare these. So many fewer places for like bugs and weird shit to hide in this than in this. I'm also, incidentally, so much more descriptive now. I'm saying like what this is doing. I take these people, I make all of them louder, and then I print them. What this is doing, I have to read so much. I have to think a lot about what this is doing. Not as good. Also, I got these two reusable functions out of this. You could, but now this function is doing two things. We want our functions to be single purpose. And also, since we're eaching through it, now our side effects wouldn't be at the end. Because you'd be loudifying, printing, loudifying, printing, loudifying, printing. That's more efficient from like a performance standpoint. It's not very functional though. It's a funny thing that happens. So for each takes a function definition, right? Console.log is a function definition. Whoa! The fuck is that? Anybody know why I did that? Yeah. You look up the definition of for each. It has these optional arguments, what the current index is and what the original array was. So it's gonna, if you're doing this point free, it's gonna give you all those. It's gonna log all of it. Probably not what we want. Coincidentally, it's because that is mega not functional. A function that takes in a variable number of arguments is called, wait for it, a variadic function. And we don't like them. It burns us. But c'est la vie, it's what we have in JavaScript. Okay, one more thing I want to show you. Let's take this exact same solution. What was the library that I mentioned yesterday? Lowdash. What if we Lowdash this? So if I want to Lowdash this, I'm going to make an npm buddy. I'm going to install Lowdash. Beautiful. Go back into the file. The most common way to do this is to just call it underscore. See if low dash. The original library was called underscore. This is a fork of it that's a lot better. And so you do something like that, and now you have that map and all those kinds of things. I'd actually rather you destructure out the particular ones that you want. So you could take out map, and I'm going to use one called flow, and let's take in an each also. So I'm taking those three functions out of Lowdash. Here's what that same thing looks like in Lowdash. We'll say flow. Flow takes in an array of functions, and then it takes a data in as a second argument, so I can take in my my people there. And then for each one of these, I'm going to run this data through every one of these functions that I put in flow. And common functional pattern, you want things that only take in one argument, in part because of, let's find it, there we go, this input-output table. It gets a lot more complicated once you have more than one input, so we try to limit things to one input so you can graph it better. Okay, so if flow is only supposed to take one input, baller, check this shit out. Every function in Lowdash, well, actually, it's a particular kind of Lowdash called Lowdash FP. We call auto curries. This takes two arguments, but you can apply them one at a time. All right, and then I want to say, I want you to map Lowbeautiful, and then each console log and there we go. And since this each isn't like for each, it's not a variadic function. Only takes in one thing. Sick! And I could also do something like, cool, I want these to be really fucking loud teachers. And what I love about this style of programming is you're making it so clear. You can just see it like a river. You start here, and then whatever the return value of this is gets passed to this function. Return of that gets passed to this one. If these were different things, we could reorder them really easily. that's such a simpler model than stuff that worries about state. Debugging something like this is fucking easy. Writing it this way, thinking in this style, that's fairly difficult. But if something's broken, it's not difficult to figure out where it happened.
Have you ever read like map Lowify times 5 or something?
Yeah, you can probably do that.
Does that sort of defeat purpose?
No, that might actually be way more clear. What I bring in times. I don't know if this will work, but I'm kind of curious now. If I did times, and data is always last in FP, so it'd probably be something like that. Yeah, shit, let's see. Let me look up the API for times. Okay. All right, so this is, I'm trying to get my head around this now. So one of the things you can do, and this is not quite the same thing as like being like stateful with variables. We can say something like const Lowdify all equals map Lowdify. All I've done is like define a different function, but there's no state in that, so that's okay. And maybe I swap this out for Lowdify all. Oh shit, that's gonna take, let's see, I could also times 5 is that, and I want to times 5, and then I'm passing in a function. Lowdify all returns a function that is, oh, I see what's happening. Lowdify all at this point is expecting data, and it is, shoot. All right, I can't do this off the top of my head, but yes, you could do something like that. Cool, what else? There's, shoot, there's a bigger principle I wanted you to take away from this that I think applies more broadly. I'm trying to remember what it was now. Oh, yes, I remember what it was now. Bigger thing I want you to take away from this is that complexity at some point can't be reduced. It can just be moved around. This is, you have a really complex front end. You can't get rid of that, but you can move that complexity to the back end, and maybe you're better off that way. Maybe not. You can make something like this super easy to debug. You can write code that's like almost impossible to have errors. It's not any less complex though. You've probably just moved the complexity to like how difficult and mathematical and fussy this mental model is. Ideally, this is what the things like Rails and Ember do. You move the complexity into the framework so that somebody else's code is doing all the hard work. You haven't eliminated the complexity, you've just made it not your problem. Remember looping versus recursion? We were talking about that. You're trading CPU cycles for memory. Which one's cheaper? Which one works with your existing architecture? But like that's one of the bigger takeaways that I want you to have out of this conceptually, is the complexity is always there, but Kind of like the end of Ghostbusters 1. Oh, who am I talking about? You guys are fetuses. There's this movie called Ghostbusters. All right, fine. So the end of Ghostbusters, like, choose the form of your destroyer. That's kind of what you get to do with code. Awesome. What questions? Gage.
You call it map modify.
Mm-hmm.
Shouldn't it return the actual string, like the teacher's name with an exclamation point?
Ah, no. So what's happening there is the return value of map is a function that you can call with an array of things. So if I keep Lowbeautiful all in here, Lowbeautiful all is a function. That's what gets returned out of this. And it takes an array and it will do this transformation on the array. And so I could make this Lowbeautiful all instead. And there's some loud teachers. That's the complexity of the mental model. Is now, since like things can return functions and they could get stored in values as essentially new function definitions, well, now you got to keep track of that. And that's not quite as intuitive as procedural programming or OOP is. Imperative programming. So you wouldn't do imperative versus functional. You do imperative versus declarative. Functional is almost always declarative. OOP and procedural are both imperative. But the difference is that, oh, actually, we've got perfect examples right here. I can't imagine much more imperative code than this. Imperative is you're telling the computer what to do. Computer, take these values, store them in this variable, then initialize a blank variable here, then initialize an index that starts at 0, and while that index is less than the length of this array, I would like you to perform the following operations and then increment your index. Instructions to the computer. You're practically talking like a computer. This is declarative code. We're not actually specifying how any of this shit even works. We're just saying what we want done and trusting that there is an implementation that works for this. It needs to get imperative at some point. You need to tell it what to do one of these days. And like, if it's not in your code, then it's some code that's being compiled to. The goal with declarative code is to abstract until you're describing what you want, and now your code reads a little bit more like a story. And declarative code is almost always preferable to imperative code, but you can't do it in every language. Like, there's no declarative SQL code, unfortunately. Yeah.
Is flow code like .then?
Kind of. You can think of it as like a .then, like a promise chain, but for synchronous code. Yeah, I'd buy that. But check that out. We did a bunch of steps. There's no stops, though. This is still, this entire program, like without the exception of pulling in these dependencies, is one statement. That's wild. What else? When do we use this kind of programming? What is this good for? It's not everything. Yep. Another way you could phrase that is transformations. You're fundamentally doing some kind of data transformation, like this is the first thing that I'm going to reach for every time. And I'm probably going to write something that looks kind of like this. You're writing a game? Good fucking luck, man. Like, that's like a joke. Like, it goes back 5 years on Denver Devs. Somebody who hated object-oriented programming so much. He's like, hey, are there any FP game frameworks out there? I was like, what are you talking about? Like, you want to capture a flow of user inputs and use that to modify it. What the fuck are you talking about? Make a class called Goblin and give it a property with hit points. Like, don't make this math, dude. And the so like something like that. I mentioned data modeling. That is like done a lot easier in OOP. But if I'm turning a set of data that looks one way and I need to make it look another way, the functional toolbox is your best friend. What else? Let's do one more. Or not. Have a nice lunch.